All right, have you ever stopped to think about how an app like Netflix or Amazon can handle millions of people all at once without just completely crashing and burning? It is, no joke, one of the biggest challenges in all of software. So let's get into it. Let's peel back the curtain and look at the core principles that make all of this possible.
To really get this, I want you to picture something. We're not just writing code. We're going up against a gigantic three-headed dragon. And this dragon, it is the problem of scale. If you don't know how to fight it, well, your system is pretty much toast before it even gets off the ground.
So what are these three nasty heads? Well, first, you've got the sheer chaos of the network. Connections drop, messages get lost, it's a mess. Second, there's the constant looming threat that your data, the lifeblood of your app, could get corrupted. And the third head? It's the creeping, tangled complexity of your very own code, which can grow into a monster all on its own. To build something that lasts, you've got to beat all three.
Okay, let's go after that first head, the chaotic network. Now, our weapon of choice here isn't just some clever trick. It's a fundamental law of the universe for distributed systems. It's called the CAP theorem.
Think of the CAP theorem like the law of gravity for software. It's not a suggestion, it's a rule. It says that when your system is spread out across multiple computers, you are forced to make a tough choice. You get to pick two of these three critical promises, but, and this is the important part, you can never, ever have all three at the same time. It's just not possible.
So what are C, A, and P? Well, C is for consistency. That means everybody using the app sees the exact same data, right down to the millisecond. A is for availability. This means the app is always online for you. It never just gives you an error page, it always responds. And P is for partition tolerance. That's a fancy way of saying the system can handle it when the network between its parts breaks down.
And here's the kicker. This is the part that changes everything. In the real world, with any big system, the network will fail. It's not an if, it's a when. And because of that, partition tolerance, well, it isn't really a choice you get to make. It's mandatory. Your system has to be able to handle network failures. So if you have to pick P, what does that leave you with? Your real decision is between C and A. Are you building a CP system? Think of a bank. It would rather stop working entirely than show you the wrong account balance. Or are you building an AP system, like a social media feed? It will always show you something, even if it's a few seconds out of date. This one choice, right here, defines everything about how your app feels to you.
All right, with the network dragon head dealt with, let's turn to the second one, data corruption. To beat this, we need a shield, a really strong one. And that shield is a set of 4 principles for databases, known as the ACID properties.
First up, A is for atomicity. The classic example is a bank transfer, right? Money has to leave one account and show up in another. Atomicity says that this entire process is an all-or-nothing deal. You can't have a situation where the money is withdrawn but never gets deposited. It either all works perfectly or the whole thing is instantly rolled back like it never even happened. No half measures.
Next up, C is for consistency. And I have to be super clear here. This is a different C than the one in the CAP theorem. In ACID, consistency means the database acts like a tough security guard for your data. It enforces your rules. So if you have a rule that says a user's account balance can never drop below 0, the database will flat out reject any transaction that tries to break that rule. It keeps your data from ever becoming illogical.
I is for isolation, and oh man, this one is huge. Picture 2 people trying to book the very last seat on an airplane at the exact same moment. Without isolation, it would be chaos. Isolation makes sure these 2 actions don't trample all over each other. It creates order, processing them one by one, so only one person actually gets that seat. It keeps everything from turning into a total mess.
And finally, we have D for durability. This is the database's ultimate promise to you. Once it says, yep, your data is saved, it means it. It is saved. You could pull the plug on the server a millisecond later, and when it boots back up, that data will be right there, safe and sound. It's permanent.
Okay, on to the third and final head of the dragon, the complexity of our own code. This one is tricky because, well, we're the ones who create it. Our weapon here isn't a theorem or a fancy property. It's a set of disciplines, known together as clean code.
The first principle is a classic for a reason. Don't repeat yourself, or DRY for short. It's this really simple but incredibly powerful idea that every single piece of logic in your system should exist in exactly one place. That one place becomes the single source of truth for that idea. So why is that so important?
Well, imagine you have the same bit of code copied and pasted in 5 different spots. If you find a bug, you now have to remember to find and fix all 5 of those copies. But if you're following DRY, you have one place to go. You make one change and boom, the problem is solved everywhere. It's just so much more efficient and reliable.
Next up, we have a philosophy that helps us fight our natural urge to make things way too complicated. It's called Keep It Simple Stupid, or KISS. This is all about pushing ourselves to find the absolute simplest solution that actually works.
And why is simple so much better? Because simple code is easier for humans to read and understand. That means it has fewer places for bugs to hide, and it means a new person can join the team and start being productive way faster. When you're building something huge, complexity isn't just annoying, it's the enemy of progress. Our last principle for clean code is a powerful defense against building way too much stuff. It's called YAGNI, which stands for You Aren't Gonna Need It. It's a constant reminder. Don't add features just because you think you might need them someday in the future.
YAGNI is what keeps a team laser-focused. It stops developers from sinking weeks into building these elaborate, complicated features that nobody ever actually asked for. Not only does this save a ton of time, but it also keeps the code itself smaller, cleaner, and way easier to manage down the road.
So there you have it. We've taken on all 3 heads of the dragon. But these 3 pillars, cap, acid, and clean code, they don't just work on their own. They lock together to form a single, incredibly strong foundation for any reliable system. They build a fortress.
Let's follow a single tap on your phone to see how this works. Your request first hits the application code, which hopefully is clean and simple. That code then turns around and talks to the database, where our ACID shield makes sure the data operation is totally safe. And finally, that data gets stored and copied across a whole fleet of servers, a process that is governed by the trade-offs of the CAP theorem. You see? All 3 are essential, working together in harmony.
And this isn't just some abstract theory, This is how the real world works. Banking systems, they have to be consistent, so they choose CP. Social media, search engines, they need to be online no matter what, so they choose AP. Any system that deals with orders, inventory, or money relies on ACID. And every single massive tech company you can think of, Google, Amazon, Netflix, they live and die by the principles of clean code.
So here it is. This is your blueprint for defending against the dragon of scale. The CAP theorem is your strategy for surviving network failure. The ACID properties are your impenetrable shield that protects your data. And clean code? That's the discipline that protects you and your future team from the complexity you create yourself.
So, the next time you're scrolling your social feed, or you buy something online, or even just check your bank balance, just take a second and think, what trade-offs are being made right now for you? Which promises are being kept? Which of these pillars are holding up that entire digital world? Because now, you know what to look for.